Cool. Good evening or good morning to folks who are joining. We'll just give a few more seconds for attendees to join. Very cool. Thank you everybody for joining. Welcome to the latest edition of the Silicon Valley AutoWare meetup. Today's topic is going to be cooperative driving automation. And welcome to our panelists today. We have joining us Taylor Lochrane, Program Manager of CARMA at the Federal Highway Administration. We have Shawn Kimmel. Sorry, where did I lost my page? Okay, Shawn Kimmel, Vice Chair of SAE's On-Road Automated Driving Committee, and John Buszek, VP of Product and Services at AutonomouStuff. Before we kick things off, just a few words by way of introduction and housekeeping. First of all, just to let everybody know that this will be recorded and will be hosted online at Apex.AI's website, where we have a section for the AutoWare meetups. While you're there, you can also look at Apex.AI and AutoWare. We are members of the Ottawa Foundation, and we have also archived there some of other presentations and meetup materials, and also the self-driving cars with ROS and AutoWare course, which is a 14-part series learning for engineers on how to actually build an autonomous system using AutoWare. While you're there, you might also look to see the recently announced autonomous valet parking that was done using fully open source AutoWare.auto software. So, so just as a reminder, please use the Q&A button to ask questions. We will have short question answer sessions during the panel. So just wait for that and I will read out the questions as they come in. Okay, a little bit about our speakers before I hand it off to our first speaker. Taylor is the CARMA Program Manager, like I mentioned, as the Federal Highway Administration. He's leading and managing the CARMA program, part of the US DOT effort to accelerate R&D of cooperative driving automation, leveraging open source and using agile development practices to accelerate innovative concepts aimed to increase safety and improve overall infrastructure efficiency of the transportation system. And the CARMA program enables a larger community to participate in development through open collaboration and testing of these strategies to enable technology from research to market. Shawn Kimmel, who we'll be hearing from next, is a robotics engineer with over 15 years of experience developing autonomous vehicles and unmanned systems, technology and policy. He directs QS2's automation and transportation portfolio, supporting efforts with US DOT, DOE, NASA, FAA, national academies, standards development organizations, and others to accelerate safe deployment of autonomous vehicles. And Dr. Kimmel serves as Vice Chair of SAE's On-Road Automated Driving Committee and participates in many AV standards efforts, including serving as volunteer organizer for the Automated Vehicle Symposium since 2015, and has conducted vehicle automation research for USPS, NPS, DARPA, RAND Corporation, and Caterpillar. And last but not least, we'll hear from John Buszek, VP of Products and Services at AutonomouStuff, where he has responsibility for autonomous vehicle system offerings, projects, and initiatives. BS in Electrical Engineering from University of Michigan and Master of Science from Oakland University. His professional background involves myriad vehicle systems, algorithms, and software development for all-wheel drive, dynamic control, and electric vehicle traction motor control. He became a technical business leader in strategy, marketing, and engineering for specialty applications such as LiDAR, surround view, and automated driving. And his focus is now on production challenges, emphasizing low power, low cost, cybersecurity, and functional safety. So welcome to our panelists. And before we jump right into our talks, I want to have a quick poll here. And if you will pay attention briefly to the poll that I've just launched using this webinar interface, just want to collect a overview of who we have in the audience today. I'll allow a few more seconds and then I'll close this poll. Thank you for your quick response. All right, so sharing the results out in real time, we have mostly engineers today here with us, and among them a lot of software engineers, which is typical for this particular meetup. We've seen that that's actually very much what we would expect. And one last question, I promise we will go right into our speakers right after this. If you could just let me know how familiar are you with cooperative driving automation? I would love to, I think our panelists and speakers would also love to know how familiar we are. So the choices we have from not familiar all the way to expert. And I see the panelists might have voted, which might explain the 3 experts we have. All right, sharing out the results. Glad to know that we have some familiarity, I think, for majority of the viewers today. So there you go. Very cool. Thank you very much. So without further ado, Taylor, please take it away in terms of what CARMA has been doing.
Awesome. Well, Sanjay, thank you so much for having us. I'm going to go ahead and share my screen. I put together some slides to kind of walk through a little bit about the CARMA program. Here we go. Let's get this to full screen mode. All right. Can everybody see that okay? Okay, wonderful. Well, today, I kind of wanted to start with, what are we doing? What is the CARMA program? What are we focusing on? And how does that relate to this new emerging area of cooperative driving automation? And, it all starts, and this is what Shawn's going to talk about in a little bit, is, there's been a great advance, I think, when we look at standards, and this new standard that just came out, the SAE J3216 came out this May, really helped shape and form what we are defining and calling as cooperative driving automation. So imagine machine-to-machine sharing of information. And so when we start thinking about, the transportation system and all these new automation, devices and road users coming together, how are they going to interface and work together so we can have a real efficient and movement of goods and people in this country? And that's what CARMA is really focusing on. Our initiative is how do we take this emerging automated driving technology and all the connected vehicle, V2X, V2Everything technology, merge them together to create the capability for these systems to share information. And could that lead to better, more efficient travel within our country? And that's really the focus of what the CARMA program is all about in a nutshell. What we did is we tried to recreate this transportation ecosystem around 3 different research tracks: freight, reliability, and traffic. And what we're trying to do is replicate this environment using open source software so that we can start to create and start to develop these new features that we can start to see and deploy and test with to figure out how this technology can really benefit our transportation community. And so within the United States Department of Transportation, this is a multimodal program, which means we're working across agencies to help lead this research, both on the traffic side, looking at the recurring congestion. How, when we look at that picture here with all those cars in traffic, how are those vehicles, if they're automated, going to be able to maneuver with human vehicles? And if they could communicate with each other, could they maneuver a lot more efficiently? And then reliability. If you're trying to get to somewhere, how can we help with the reliability of going through work zones and weather and all these different things that happen along a trip? How can we, as state and transportation agencies, really support that with this technology? And as we know, freight is increasing across our country, especially with delivery of delivery type services. So as we look at the increase in freight, how can this technology really help benefit? And so we're working across DOT modes, and we're pretty excited about that. But what CARMA has is these 3 different areas that we talk about: the products, the evaluation methods, and then the way we engage with our community, in this community that we're really creating. In the product side, we have you know, CARMA Cloud, CARMA Platform, CARMA Messenger, and CARMA Streets. And they're all open source tools that help create these components in the system so they can start to share information. And we can start to develop algorithms and really think about the unique capabilities this technology could provide for our system. And then we have a lot of different tools to help evaluate how these systems are operating and how they're performing, so we can really define the benefits and help lead to those successful conclusions of how this technology can be deployed. But the main ingredient, I think, of what CARMA has is our engagement and how we're going to collaborate and how we can collaborate with each other on the development of these concepts and how we can share what we're learning through open source. And we're also here to help you get started with support. So CARMA Support is a group of our engineers that are available for you as you start to think about how cooperative driving automation and how you want to use this software to help you move this industry forward. And so here's some more information about CARMA Collaborative and CARMA Support. You can contact CARMA Collaborative and join today. And CARMA Support, again, you can email our team at any time. As you can see, we're engaging heavily with the academic community as well as the industry. And so we have a lot of our academic partners kind of listed on the states on the right-hand side. We also have a lot of information on our federal highway site. All of our source code is on GitHub at our GitHub link. We keep a lot of documentation. So as you're wanting to get involved in some of this software and as you're trying to get involved in CARMA, Confluence, as well as Jira, where we manage all of our agile activities. And then we started a new channel at Ross Discourse, you know, with the open robotics folks to really start focusing on some of these technical questions within the community that also AutoWare and Apex are heavily involved in those discussions on advancing a lot of the autonomy that they're leading within the industry today. So with that, I'm going to pass the mic over to our next panelist, but this is a quick introduction of CARMA. Thank you.
Thank you, Taylor. Let me see, there are no questions here, but if you have questions, please, let's take a moment, and this may be a good time to ask Taylor before we move to Shawn to give you a little of his perspective. So remember, there's a Q&A button there. Please go ahead and use it, and let me know if there's anything that is on your mind. If not, before we jump on, I'm gonna see if folks are still paying attention by launching another poll. All right, take a look at that and see the question asking that I will read out is based on CDA research. Autonomous vehicles working together with roadway infrastructure will increase safety and improve operational efficiency by which of these following 4 methods? Improving situational awareness, doubling capacity and existing lanes and freeways, reducing energy consumption at traffic lights, or all of the above. I'm going to end the poll because clearly the winner is pretty obvious in this case. I think we're all convinced that there's just so many ways in which CDA will improve our lives. Okay. I don't see any other questions here, so let's move on, and we will have more opportunities for questions at the end. Go ahead, Shawn, and take over the screen.
Great, thank you so much, Sanjay. All right, so that should be coming through now. Well, good afternoon, evening, or morning, everyone. It's really exciting to be on a call with so much of a international flavor to it sometimes, because I think this is certainly a technology that crosses borders, and the interoperability of the technologies across those international borders is going to be really interesting. I was also really interested to see the mix of folks on the phone, so not just engineers, but business and other backgrounds. So I think this presentation may help speak to some of the aspects of cooperative driving automation that are not just technological in nature. So to start with, I wanted to reflect on driving automation, since that's really the kind of building block component of cooperative driving automation. And driving automation is defined by J3016, has 5 levels, which you see on the left here. And the lower levels of automation, or 1 and 2, the human is still in a loop. And then as you get to the higher levels of automation, levels 3 through 5, there the automated driving system is performing the dynamic driving task. And that's actually really important because that's where you can achieve a lot of the benefits from cooperative driving automation when you have that machine control of the system. So that's automation, but now how do we take it to the next level? And this is really important. Cooperative driving automation enables mobility applications that are not otherwise achievable by an individual ADS operated vehicle that operates independently of other vehicles around it. This information that can be shared amongst road users, including other human-driven vehicles, other ADS, other pedestrians or bicyclists on the roadway, and also, cell towers and backhaul offices with information. All this information can really improve the ability of these actors to navigate and control the transportation network. And so that sharing of information can increase the safety, efficiency, and reliability of automation, as we learned from our poll today. And there's a lot of potential here for cooperative driving automation. And so let's take a closer look at some of the aspects of automation that benefit from cooperation. And so this is a bit of an eye chart, but I just wanted to call out all the different functions that exist within an automated driving system because there's a lot of different use cases for cooperation, and it really depends on what aspect of the ADS may be using that information in terms of what the performance characteristics will need to be. How accurate will that information need to be? What's the latency? What's the, how fresh does that data need to be? How recently does it have to have been collected? All those things can really drive whether or not that information is useful. So you have here, perception functions where a vehicle is detecting what's around it based off of its sensors. You have localization, so finding out where it is within the world. These static and dynamic world models that are getting updated as the world changes and as the vehicle becomes aware of the objects in it. And then there's this whole planning and control stack on the right here. And so cooperation can inform functionality at all these different levels of automation. But in order to do that, it depends on a common language to coordinate between diverse stakeholders that are preparing for and deploying these cooperative driving automation use cases. So to develop cooperative driving automation, SAJ 3216 does a lot of things. Some of those things it does is clarify the types of information to be exchanged during cooperative automation operations. It clarifies the capabilities that may be required. It answers questions about scope when it comes to developing laws, policies, regulations, and standards. Provides useful framework for cooperative driving automation standards, specifications, and technical requirements. Provides clarity and stability in the communications on top of cooperative automation. And just generally builds a foundation for a reference point for standards moving forward. So it provides definitions and taxonomies. And so I'm going to go into the taxonomy here for a moment. And so this table here maps the cooperative automation classes on the left to the levels of driving automation on the top there. And just going down, we've got the class A, which is status sharing. That's here I am and what I see. There's the class B, which is the intent sharing. Here's what I plan to do. There's agreement seeking. Let's do this together. And class D, prescriptive. I will do as directed. And then so at each of these levels, as you go to the right, you see that there's different types of functionality that can be enabled. So at the class A and B, you're getting information about object and events and their current status. And then at intent sharing, you're actually have the potential to improve your prediction of what the future state will look like. Then at class C, you can attain mutual goals through coordinated actions. And then finally at class D, there you're actually having some aspect of control handed over to an entity. So for example, like a speed limit truck or something like that. And then one important thing to notice here is that I alluded to it earlier, but on the left here, these lower levels of automation, they're limited in some ways because the human can take back control of the vehicle at any time. And the sensors on those systems are often more limited in their capabilities than on the higher levels of automation. So a lot of the work we've been looking at recently, and we'll look at the future, is kind of on the right side of this with cooperative ADS or CADS for short. So what's ahead? There's a lot of different standards activities, and so SAE and with support from QS2 has taken a look at the standards ecosystem to identify not just where we're at now, but where are we going? How are we going to enable the kind of functionality that's needed? You know, what's the interoperability? What's the performance requirements? All that needs to be determined and in a coordinated fashion with lots of different SDOs, standards development organizations working in this space. So this roadmap SAE developed lays out some of the standards needs. And then as you can click into some of these boxes that are here, it'll give you more information about that standards need, who may be pursuing it. And so this is, you know, it covers a lot of different areas, but cooperative automated driving is definitely a focus of the roadmap. And so you can see there at the top that yellow outline is around the J3216 definitions and taxonomy, but there's a whole slew of needs yet to come. In that testing area there, that's really where open source software and testing platforms can provide a lot of value, because one of the key things about this technology is that it's not developed in a silo. It really depends on different technology developers and providers working together. So that needs to be tested in an environment, a distributed environment, including functionality like co-stimulation. And so that's where standards and open platforms, I think, will really have a key role to play, and the CARMA platform being really a major place where a lot of that community is being developed. And then the use cases down here below, there's a, you know, it's kind of at the end of the day, what's the, you know, is the juice worth the squeeze? These are the applications where you're going to get mobility benefits, you're going to get energy efficiency benefits and safety benefits. And so here's just a few of the upcoming and ongoing standards activities that are focused around cooperative driving automation applications. So they're kind of self-explanatory, and in the interest of time, so that we have some room for discussion, I'll stop there and hand it back to you, Sanjay.
Thank you, Shawn. That was very interesting to hear the SAE perspective. There's one question that maybe we should take right now, and the question is, level 3 and above systems invariably have their own maps and localization systems. Is it plausible that such vehicles would have any use for externally sourced map or localization data, and what's the use case for that kind of sharing? And feel free, any of you, to actually jump in to share your answer to that question.
Yeah, I guess my last slide, maybe I should have spent another moment on it because it does show some of those use cases, but to walk through them, cooperative perception is one. So for example, you may be, your sensors may have visual occlusions due to, say, another vehicle on the road, and things that are behind that vehicle may have an impact on your future trajectory, like a pedestrian who's walking out in front of a bus, for example. So it's helping with kind of quote unquote seeing around corners, and then there's examples where maybe the accuracy of the information you get, you may have a high uncertainty bar on the location of something based off of any number of things, and so these are maybe pieces of information that can help you reduce the uncertainty bars on where something's located. But certainly at the end of the day, the automated driving system has to be validated, and using outside information to make decisions certainly introduces an additional risk into that process. So it's, that's why I think the standards are going to be really important to define some of those performance characteristics so that there can be trust built in this system, and that information can achieve some of those benefits that otherwise wouldn't be able to be achieved.
Very cool. And another question about what's the difference between CDA and applications of V2X?
Okay, so that's a good question. I think you think about the V2X applications, most of them were developed and designed around the connected vehicle architecture. So how do you share information that could be beneficial for a human driver around the red light runner or such activities? And so CDA kind of takes that starting point and goes further and says, okay, let's not only look at humans and what information could be valuable for helping them in their decision making while they're driving the vehicle, but start thinking about the automation and what the benefits of automation can start to do. So that's kind of the, so V2X kind of now lives in CDA as the earlier lower parts of the table that Shawn described at lower ends of automation. so that's a good way to answer that question.
Yeah, maybe just to add to that, I think one of the major differences between a human and an ADS is that if you give a human a piece of information, they're the ones still liable for what they do with that information. And at the end of the day, an ADS has to figure out what to do with that information, and without that human oversight. So that really does drive some differences in the performance requirements for those applications. And maybe actually to add on to it further, I think there's also benefits that you might not be able to gain, because things like because the ADS could actually negotiate and have a agreement with another vehicle that it's going to let it in. It's kind of like the virtual hand wave, go ahead. That's something that I think is very different between a human and an ADS.
Cool. Thank you. Thank you for those. So now I know what we've all been waiting for is really to hear about what the industry and the companies are doing with this. Actually, to see if that is in fact what we've been waiting for, I'm going to launch another quick poll. If you'll let me know and let our panelists know, what kind of organization are you actually affiliated with? Is it in research, in government, commercial sector, or something else? Just to give us an idea of what you might be working on and where your interests might lie. Thank you for your response. I'll leave that up for a few more seconds. Okay, so it does look like there's a lot of companies being represented in our audience. So for sure, let's go on to our final panelist here, whom we haven't heard from yet. Thank you, John, for patiently waiting. Please tell us what companies like yourselves are doing with this concept.
Absolutely, Sanjay. Definitely excited to be here. I think just excited to be a part of anything that's improving the safety and efficiency of roads. And as you saw in Taylor and Shawn's presentation, CDA is certainly doing that. Matter of fact, I really like Shawn's presentation. I always felt that when you see a standard start coming to life in SAE, that's when you know it's big, it's serious. So, and I think CDA is something that's good. It's going to become that. If I go ahead and share my screen, so you don't just have to look at me. There we go. We can talk a little bit about how we are utilizing CARMA and CDA in industry. And for those of you who are familiar with AutonomouStuff, you could think of us as like the ultimate enabler of research in autonomous driving. So all the vehicles that you see on this slide here, we could provide to you driving autonomously to some level. And we put over 500 of these vehicles into the market. And the idea is that one of these vehicles can be provided to you out of the box, running open source software. And we've had a huge investment recently to make sure that we're ready to help our customers utilize CARMA for various CDA applications. Here you can see a typical architecture that you might find in one of our vehicle platforms. All the sensors that you would expect to see. You have the V2X or CV2X component there. That's a part, I guess, a component of CDA, and CDA takes the application next level, as Shawn and Taylor were saying. Along with the rest of the architecture, you have your flexible compute platform for developing algorithms quickly, for developing neural nets for different types of perception, and then the by-wire layer that we've put in many different types of vehicles. That's a key part of enabling autonomy in different types of vehicles. And when you see all those vehicles, you say, well, what software is running on there? And almost every time, the software that you're going to see in one of our research platforms is open source. Right? If you're an engineer, what would you rather have? A powerful open source stack that comes in your research platform, running out of the box, that you can learn from, that you can test, and that you can change into whatever you need it to be. And so we have a lot of focus on AutoWare, certainly, and now CARMA is really starting to build up as one of our competencies, because we're just seeing the value of CDA in industry and in academic research. In terms of testing open source software, we do a lot of live traffic testing in Peoria, Illinois. And then before we go into live traffic, we test out any open source software on the full vehicle platform at our closed course facility in Ottawa, Ontario. Here I could show you a video of some testing that we do in live traffic scenarios in Peoria. And this is one of our vehicle platforms running open source stack. So you can see the vehicle trajectory, different objects that we're detecting in the environment, going through an intersection here. We detect it with a front-facing camera. And you know, the idea of what you're seeing here is this isn't ours. This is something that we're trying to provide to as many engineers as we possibly can to accelerate any development of autonomy in as many use cases as possible. You can see here we're even tackling some tough on-road situations with a roundabout. I can tell you that it doesn't work as well every time as you see in this video clip, but it works enough to where it's certainly valuable in research for many engineers out there. And so along with the work in Peoria, we have the team in Ottawa that's really testing this open source software, whether it be AutoWare, whether it be CARMA, to make sure that if you receive a vehicle platform, it's going to function exactly as we intended it to. And so, you know, the goal of our business is to be able to show up to your facility with a research platform that you purchased with a certain amount of open source software running out of the box. In this case, it would certainly be CARMA. And then we would give you a bunch of training on site, and we wouldn't leave until that vehicle is running the functions that you expected to run at your site. And until we felt that you were comfortable to use that vehicle to start driving after all your research goals. And in the case of CARMA, we're just super excited to be contributing in any way. As you can see here, lots of vehicle platforms that we've been able to contribute to the program. They certainly look beautiful in these photos there, and a lot of hard work went into bringing these vehicles to life and making sure that the software is running correctly on them. And when we talk to our customers about CARMA or any open source software, you know, they always want to see the roadmap. And when it comes to open source software, I've seen customers, and they always want to make sure that they're investing in an open source software stack that's going to be there for the long haul. They want to invest in an open source software stack that has a strong community of users behind it. And they want a software stack that has a nice roadmap of cool features that's coming. And as you can see, CARMA certainly checks all those boxes. You know, if we start looking at the near-term releases, things that are coming out this year, we've certainly seen lots of interest in the university sector for utilizing this for CD applications that can help with traffic congestion and freeways. And also, we've seen some desire to utilize CDA for improving fuel efficiency in freight applications. I think a next application that we're starting to hear about in customer conversations is work zone management. The idea that vehicles could work with the environment to know where the construction barrels are, where the cones are, certainly a difficult perception problem. And anything that we could use through CDA, you know, could make that type of scenario more robust in terms of performance. When we're talking to customers in industry, certainly they want to know when things are going to move to ROS 2 for lots of reasons. Many of you probably are familiar with ROS 2, but when you're working towards production, you know, having software with a little bit more capability in terms of real-time performance is always desirable. Another interesting one that we've seen that we think will be supported with this Zephyr release in March is the use of CDA to help prevent collisions with heavy-duty farming machinery. In some rural areas where you have very hilly roads with limited visibility, there's been some very unfortunate accidents. And so we've had some universities that are looking into how they could use CDA to reduce, right, those very unfortunate scenarios. And then when we talk about farms, you know, that kind of leads you into the whole topic of off-road applications in industry. And, you know, the on-road application is incredibly difficult challenge, particularly in the cities. We're seeing a lot of progress in like the robo freight and other freeway-based applications. Maybe it's a slightly more simplified overall problem. But I think we've seen a lot of mature applications of different levels of driving automation in off-road applications. And we are really excited to start exploring how CDA and CARMA can be useful in these applications that are maybe a little bit closer to production. You know, you can see here in agriculture with the concept of an auto cart, which is like a machine that's tethered to a manually driven machine via different features that you could find in CARMA. You think about mining with all these heavy duty machines where you really want to avoid collisions, but you also have difficult visibility conditions in terms of night usage, in terms of dust. You know, I think we could see CDA applications being really helpful there. You know, airports, you think about trying to plow snow in a blizzard, which airports need to do, another great application. So you can see on and on, and it's amazing when you think about CDA and all the ways that couldn't just help on-road applications, but also potentially off-road applications. And then I got a quick little video here from an off-road environment, and you could see one of those applications of auto cart in agriculture. Maybe I can, for the sake of time, skip forward a little bit. But you can see one of our no safety driver-based by-wire applications, and having adequate level of perception to be able to detect obstacles. And here you can see it's detecting a pedestrian and stopping. And then also you can see some examples of connectivity applications in the off-road environment. Skip along here. There you see. And that was what I had for today. So I'm ready for any questions from you guys.
Very cool. Thank you, John. That completes our presentation material. And so we wanted to make sure we have time for Q&A. So please do ask your questions. I'm going to get the ball rolling with a question to Taylor. If you can just give us a little bit of history and background of CARMA and how long that's been around and what are the goals that were originally envisioned.
Sure, yeah. So CARMA started in DOT back in 2013. We were focusing on how can vehicles share information so they could follow closer. And we were trying to look at the potential capability of increasing lane capacity on a highway. So that's the topic of cooperative adaptive cruise control. And that's kind of where CARMA started. We also looked at an arterial application for eco approach and departure. So how can vehicles use signal timing information to plan their trajectory in approaching the signal to improve their fuel efficiency? And we saw a lot of benefits of, I think, 20 to 25% fuel efficiency savings projected from some of the experiments we did, as well as, you know, some of the CACC functionality were leading to numbers of about doubling the capacity, both in simulation, but also within our vehicle testing. And that was all level 1 research, SAE level 1 research. And so as CARMA migrated from its first generation, focusing on, you know, if vehicles could share information with each other in infrastructure, could we start to see some mobility benefits? We moved into the second generation of CARMA, which is when we transferred from, you know, that rugged engineered system that we built with all these parts to create something that never existed, to moving to ROS and moving to open source. And that was a big culture change in the government, as, you know, we weren't doing much open source in the federal government. And a lot of people didn't know what ROS was in the transportation sector. It's very popular in the robotics side. And so making that move and migrating all of our research to then to advance from just focusing on a single application to the trip, right? So you're going to get on the highway, you're going to merge, you're going to change lanes, you're going to change speeds, and you're going to leave the highway, you're going to diverge. So there's a lot of activities. And so that's what the second generation of CARMA was focusing on. However, we still were at the level 1, let's say automation level of functionality within our software, but we made the move from proprietary and closed source solution to open source and ROS. And that was the second generation. And now we're in the third generation of CARMA, which is more focused on the ADS side. So we believe that the functionalities and features that can come from an ADS, if we can add that connectivity, right, we believe that we could do a lot more than having a human always in the loop, because we felt like some of the applications were going to be difficult because you never know if the human's going to take over in the middle of a vehicle platoon, and that might be an unsafe scenario. So we moved into the level 3 activities and partnered with industry to build and purchase these systems because we wanted to have systems that industry is using. And that's kind of where we migrated to this third generation of CARMA back in 2018. And when we also opened our GitHub repositories publicly, which we now develop in the open, as you saw from John's presentation, we're trying to keep a 1-year outlook that we update that roadmap every month. So you know what we're working on, because in the art of collaboration, there's a lot of features in that you guys might want to write proposals knowing that they're coming to then take that feature and do something better with it or do something beyond what we're doing. And hoping through this open source collaboration capability that we've established, I think we're growing with users. We're having about 5,000 users go to our GitHub site now per month. And that goes back to, if you go back to when we opened our GitHub site, we were only seeing about 10 to 20 to 30 to 40 people per month. So we've really grown the program where we have a lot of movement. People are downloading the software, they're using it, and they're starting to contribute back. And so as that culture continues, and as we continue to make that investment in understanding what CDA can bring to this community, that's the true value of what CARMA is offering. Again, we're not developing CARMA for you to adopt it into it to be a deployable system. We've developed CARMA so that you can help us develop what these CDA features can do, so you can bring that functionality to your own product and bring that product, your own product, to market. So think of CARMA as an enabler, like John said, and then working closely with SAE in the industry to help us define what CDA is. So it's not the government defining CDA. It's we're working with industry to design and to develop these standards, and I think that's a good role of government in partnership with the industry in that sense. And CARMA is just our tool. It's our tool to help us evaluate and understand these benefits that we're investigating. So that's kind of the history and the evolution of the 3 generations of CARMA. But we're very excited that it's open source. We're very excited about our community of users, and we're continually trying to expand this community, and it's continuing to grow.
Thank you, Taylor. It's fascinating to hear the good work that government-funded research is actually enabling so many things in the industry. There's been a question which I'm gonna ask any of our panelists to answer, which is about security. Some companies might shy away from V2X because of potential security issues. How do you respond to that?
I'm happy to take a first cut at it, and both can layer on. So yeah, absolutely. Communication security is going to be critical, especially for safety critical applications. The security needs will differ by each application, but will generally be an important factor. So security happens. Maybe let's reflect on other transportation modes that have been able to do this successfully. Like in maritime, there's AIS. In aviation, ADS-B. So there's solutions for having communications be secure. The question is, how do you do it in transportation? And so you kind of have to look at all layers of communication stack and think about security at each of those layers. So it happens at the credential management level, and DOT is doing work on security credential management. But actually, one of the activities SAE is planning to kick off soon, kind of developing the work in progress scope right now, is for security of CDA applications. So certainly a challenge, but there's a lot of groundwork that's been done in the V2X space that we'll be building on. And I think the drive is there. The interest is there at the folks that we've been talking to at SAE. So yeah.
I was just going to add. I agree with Shawn. I think there's certainly challenges there with security. Also, functional safety. When you have anything outside of the vehicle contributing to things the vehicle's doing, you have to ask yourself, how is the overall system of systems functionally safe? So there's all these challenges. But I think, they're amongst so many challenges in autonomous driving. And I think, we're pushing forward because we see the endless benefits. And I think in the case of CDA, and particularly V2X, there's an incredible benefit in terms of the robustness of perceiving the environment if you can establish some level of connectivity. We definitely see that in off-road environments, right? In controlled environments. If there's any way that you can apply something like V2X to the automation system, you definitely do it because of the tremendous advantages it brings. Perceiving the environment with LiDARs and cameras is very difficult. So I think, there's challenges, but certainly worth battling through those challenges and getting to that really nice end result.
Very cool. There's another question about, does CARMA include a messenger component to communicate with vulnerable road users, VRUs, or other less capable vehicles?
Yes. So for the CARMA ecosystem, we kind of explain it as, imagine that, in our architectures, we have a V2X stack or a message translator component, and we're leveraging a lot of open source software that we developed in what's called the V2X hub. And so that is the software that we're using to enable information to be shared between CARMA platform for a cooperative automated driving vehicle, and CARMA Messenger, which is our connected vehicle product line, where you have a human driver and you're still sharing information to the human, and CARMA Streets, which is our edge device, as well as CARMA Cloud, which CARMA Cloud has many components. And two of the components, one is what we're going to call CARMA Command Center, and that's where the infrastructure provides new rules, right, around what the work zone looks like, what the new speed limits are, what the minimum gaps are during a rainstorm to improve the safety of the system, and as well as CARMA Analytics. So if we look at how we're developing this, we're trying to leverage what we have built to create that connective tissue, but then also we want to merge into new emerging technologies. There's a lot of work being developed in Eclipse Foundation with DDS, and looking at that middleware that's now coming with ROS2 and Zeno and some of these other features that industry is really advancing, this connected layer. We're trying to really develop these capabilities in this platform so we can test across all emerging technologies to really get that feature to share information established, because that's very fundamental for what we're trying to do with cooperative driving automation. And hopefully what we learn in this research helps feed them back with Shawn and company at SAE for how this system's performing, and that might help SAE understand what the right requirements might be for a system, and what the requirements will be for that V2X component that might need to be added to each of these systems.
And there's another question about any plans to align CARMA and AutoWare even more than they are today. And if I can combine that with this question of any specific V2X standards that you're thinking of.
That's a great question. So the way we architected CARMA today, it's really integrated with AutoWare already. So we have most of the components for the ADS functionality are straight pulled from the AutoWare software, and we worked closely with our partners at AutonomouStuff and Tier 4 in developing and building the CARMA platform as it is today. So the question that we're starting to architect and starting to discuss is, as we move to ROS2, what does that look like? What is our architecture going to look like when we move to AutoWare to Auto under the ROS2 ecosystem? And then how does that interface look like for Apollo and other systems that are on the market today that our partners are using? And so we're trying to think outside the box as to what that architecture is going to look like. How do we interface with these other systems? How do they interface with us? We're going to be starting a technical working group under CARMA Collaborative on architecture, so we can start having these discussions with the community as to say, okay, what is the best way we can architect some of these solutions in our migration plan? As you saw on the roadmap, our migration is estimated to be done around August of next year. And right now, most of the migration is around, getting to the right Ubuntu and getting to the right distribution of ROS so that we can make that jump to Foxy. And so a lot of the base work we can do today, but there is a lot of time that we want to have this discussion with you all in the community as to the architecture And what is that, the way we're architecting Ottawa to auto and CARMA platform moving forward. So we're at kind of a really good transformational place on that.
Cool. Anything to add from any of the other panelists on that? If not, I will.
Hey, Sanjay, I was just going to say,
yeah.
We, at least on the AutonomouStuff side, we've been real excited to see I guess you could say the synergies, or maybe the cross-pollination in terms of the AutoWork community and the CARMA community. It's just been great to see, you know, the AutoWork community start also being exposed to CARMA and vice versa, right? Where CARMA users can also become exposed to AutoWare. And just with them working together, I think it's a really positive impact on autonomous driving as a whole, as opposed to different open source communities kind of being in silos. So it's been nice to see that, see those overlaps.
Very cool.
I guess one other thing I'll just quickly state, a federal highway did join the Ottawa Foundation. So we do participate in the discussions with the Ottawa Foundation on this. And I think that's a really good sign of what our commitment is to being open and working with the community. So it's not just us creating our own working group and doing our own thing. Is that, you know, we've been a member for a year, we're going into year 2 now. And we really believe in what this community is trying to do. And we're trying to find that right solution. It doesn't break the community, but like John said, brings the community together.
Cool. So just, I'm going to launch a quick poll, partly because this is my last poll, and I want to see what people are taking away from everything that they have learned today. The question asks, what are you most interested in seeing cooperative driving improve? And there's 3 choices: improving safety and flow of traffic, supporting movement of multiple vehicles in proximity to each other, or improving situational awareness efficiency. I deliberately took out an all of the above choice here, so you have to choose one of your favorites. Oh, actually it's multiple choice. So you can literally choose all 3 if you want to. Okay, I'm closing the poll. I'm going to call this a tie with a slight bias towards improving safety and flow of traffic. Looking at that, I just want to toss that back to the panel to see if there's any thoughts you have on what you would like to see improve as a result of all the work that you're doing. Shawn, do you want to go first?
Sure. I think the deployment of automated driving systems is going to be a boon for safety as long as it's done well, and I think we're on a good track there. But I think what I'm excited about is that that's just the beginning, and there's so much more. I think there's a lot more safety benefits that we're going to be able to get out of cooperative driving automation, and there's just still way too many fatalities on our nation's roadways these days, and it's I think it's a really, there's a really great opportunity here to seize on, the types of technologies that exist in other transportation domains, and it's tough. It takes a lot of people to work together to figure it out, but I'm really excited about the safety benefits that it's going to achieve.
I can go next.
Yep.
I definitely agree with Shawn. I mean, safety is, I think what it's all about. The other benefits in terms of, traffic efficiency, things like that are great. But safety is the thing that it's just so impactful for everyone. And just excited to see the traction that CDA is getting, seeing these standards developed in SAE. That's fantastic. The use cases in Shawn's chart at the end with the cooperative perception, for example, it's so difficult for a vehicle to perceive its environment and achieve situational awareness. And the thought that the environment could give the vehicle more information about its situation, about its surrounding is powerful, and just gets you excited that we're going to be able to continuously make roads more and more safe.
Very cool. There's a question about where is the CARMA community channel on Discord, Slack, Ross Discourse?
So yes, we have, we've established a CARMA channel on Ross Discourse, and we're starting to populate that with topics. So that's there. And also we have a Confluence site where we actually just met today. We're re-architecting all the different pages because we have so many pages in Confluence and so much information. We want to make it easy for you to find and participate on. We are thinking about, you know, how do we open up we use Slack internally when we're starting to think about how we use that. But as we establish our technical working groups around architecture, like I said earlier, we're also setting up one around simulation. And that's going to help us look at our simulation tools for both traffic simulation and vehicle dynamics and merging them together. And then injecting CARMA tools. So now you don't need to buy the vehicle at this time. You can do a lot of simulation work. And that's a huge community that we're trying to engage. But we want to run the real software in that simulation because eventually you got to run the experiments on the vehicle on a closed test track, like John proposed, and especially in City Pilot. I mean, that's a great place to run these experiments. So we're trying to open the door for all these different avenues for communication. And that's kind of what we have set up for today.
Very cool. I think you've also answered the question about how does simulation play into these efforts. But if there's any of the other panelists who want to talk specifically about simulation, go right ahead.
Yeah, I think this is a fascinating one because just in general with automated driving systems, simulation is such a huge enabler. And, it's kind of happening in all these, there's all these emerging simulation tools and capabilities. And, it's like this currently that early stage of, VHS or Betamax, like what's going to be the simulation tools that emerge. And I think cooperative driving automation is going to be one of the magnets that pulls it together towards some common solutions. And I think there's, a lot of, opportunity for common simulation platforms that can enable people to both develop and validate their system's functionalities through a simulator and through some simulation interfaces. And there's a lot of great work being done out of the Awesome Group in Germany, and others that are developing some of these open interfaces that could let multiple simulation nodes interact with each other and let different people understand how their technologies are going to interact. Because I think when we see it's out there in the wild, we don't want to be necessarily seeing things for the first time. Then to be able to validate something in simulation is going to be a very powerful enabler. And I think cooperative driving automation is a catalyst that will drive some harmonization there.
Very nice. We are running low on time. I'm going to take one last question, partly because it's hinting at what's coming next in our series of this AutoWare meetups. The question is sort of seems to take a different spin on what CDA is, from cooperative driving to competitive driving automation. And the question asks, how can we apply CDA to autonomous racing? For example, the recently announced Indy Autonomous Challenge.
So I know that, John, you guys are partners in that program. So you probably have a good answer to this question. So I'll let you go first and then I'll circle back.
Absolutely. A big part of racing is, of course, positioning yourself with respect to other vehicles and predicting their motion for sure. And I talked earlier about how in off-road environments, you have that advantage. You're in a controlled environment. You can know that every vehicle is equipped. And that is definitely the case in IndyCar racing. So we're contributing to ideas for some of the architectures in the IndyCar Challenge. It's going to be an amazing event, by the way. And I certainly could see applications in the architecture for the advantages of CDA.
And I think I've had this discussion, with folks from the Indy Challenge. And Joe, I appreciate the question. I think the value of open source is what software can we leverage from the CARMA platform that can help add that information that the indie vehicle race cars could be sharing with each other to maybe ensure that they're not going to collide, right? So it could be a collision avoidance type application and other features that could come about when you're sharing some of your situational awareness information to support each other's for safety critical type scenarios. So I think there's an opportunity there to look in the open source culture and see how can what we're developing in CARMA support the challenge, and then what the challengers use with that software and how they advance it, right, could help our program and help all of us that are not looking at racing, but could leverage what we understand about the challenges that they face in that very dynamic environment, right? So I think there's a lot of learning both to that community and then learning from that community how they performed, how they used it. I think there's a huge opportunity in that space.
Excellent. Thank you very much. That's all we have time for this episode. Thank you to all our presenters for making it and giving us their perspectives. It was hugely valuable to hear from all of you, and I hope the audience enjoyed it. And like I said, we're planning a future event where we will talk specifically about racing and how AutoWare is enabling some of those applications too. But in the meantime, thank you. I will close it now, and thank you one more time to all our presenters and all panelists today.